If one day Earth is no longer suitable for human survival, among all the potentially habitable planets we've detected, could one of them become our new home? In recent years, scientists using multiple astronomical telescopes have discovered more than 5,000 exoplanets. At this rate, in the Milky Way alone there are hundreds of billions of planets. Among them, planets located in habitable zones like Earth are estimated to number at least 300 million. But in our search for these worlds, we may be overlooking a cruel truth. Even if our spacecraft could cross light years and deliver humans to those planets, colonization is still destined to fail. It's not that our ships aren't fast enough, not that we can't carry enough oxygen. It's that from the very beginning, the universe set barriers for humanity that can never be crossed. They are hidden in the genes of life, written into the very bones of physical laws, and even buried deep within the roots of civilization itself. We think we're heading into the galaxy to pioneer new worlds, but in reality, we're crashing into a prison whose doors were welded shut long ago. We often believe the immune system is an all-powerful shield, forgetting that all its experience comes from 4.6 billion years of evolution on Earth. All Earth life shares the same biochemical code: carbon as the backbone, DNA as genetic storage, 20 amino acids to build proteins. Even the oxygen we breathe and the glucose we metabolize are the result of billions of years of biological negotiation. But the biochemical logic of alien life may fundamentally oppose ours. Scientists speculate that on some planets, life could be silicon-based, stable in extreme heat or extreme cold. Such silicon-based microorganisms might not need oxygen at all, surviving by absorbing stellar radiation or mineral energy. Their metabolic waste could be silanes, highly toxic to humans, capable of breaking down human tissue like dissolving plastic. Even more brutal is the fact that colonization is not a one-sided invasion. Earth's microorganisms could become cosmic destroyers. Take cyanobacteria, for example. They can perform photosynthesis in oxygen-free environments. If introduced to a planet with liquid water but no oxygen, they could rapidly blanket the surface, strangling native life that depends on anaerobic conditions. Our bodies are products sculpted by Earth's gravity over millions of years. Adult bone density, muscle tension, even inner ear balance, are all precisely tuned to a gravitational acceleration of 9.8 meters per second squared. This tuning isn't a habit, it's factory settings written into our genes. Change it, and the body begins to collapse at the cellular level. Mars, for example, has only 38% of Earth's gravity. Humans living on Mars would lose muscle mass at about 1% per month, because the body decides it no longer needs that much muscle to fight gravity. More deadly still is bone density. Astronauts on the International Space Station lose significant bone mass after just 6 months in microgravity. If humans reproduced on Mars, their children's skeletal development would fully adapt to low gravity. Their leg bones would be thinner, spines more curved, and even rib cages smaller to reduce breathing resistance. After a few generations, if these Martians returned to Earth, they would collapse under their own weight, unable to tolerate Earth's gravity or atmospheric pressure. Super-Earths, planets with more than twice Earth's mass, are a different kind of torture. In double gravity, a 60-kilogram person would feel like they weigh 120 kilograms. With every step, the knees would endure twice the stress. Human genetics cannot be rewritten in just a few generations. In the end, gravity always wins. Even if we overcame all these challenges and successfully reached a habitable planet, how would they stay in contact with Earth? Here we encounter a basic physical law we often ignore. Information can never travel faster than the speed of light. This is not a technological limitation, but a fundamental rule of the universe. Take Proxima b, about 4.2 light-years away. Sending a message saying, "We've landed successfully," would take 4.2 years to reach Earth. Earth's reply, "Congratulations," would take another 4.2 years to arrive. A single exchange takes 8.4 years. For a planet 100 light-years away, one round of communication takes 200 years. This time lag would plunge colonies into absolute physical isolation. They couldn't rely on Earth's technical support, nor share Earth's cultural achievements. By the time technology arrives, it's already obsolete. Even more frightening is civilizational divergence. Colonies would develop their own languages, values, even beliefs. After 1,000 years, they might no longer consider themselves Earthlings. Earth would become a mythical blue homeland from legend. Two civilizations would drift onto completely separate paths in the universe. Suppose we somehow overcame all previous barriers and built generation ships capable of lasting tens of thousands of years, with complete ecosystems allowing humanity to reproduce for millennia, before finally reaching a target star system. Even then, a deeper paradox awaits us. Missions erode with time, and civilizations lose themselves while drifting. The core technologies of generation ships, Ecological recycling systems, engine maintenance, must be passed down through oral teaching or digital archives. But digital data degrades under radiation, and oral transmission mutates through misunderstanding. Worse still, future generations may simplify technology to save resources, shutting down unnecessary instruments, deleting useless records of Earth's history. Eventually, critical knowledge is lost, and the ship becomes a drifting vessel with no destination. Most crucially, resources aboard the ship are finite. Population growth and uneven distribution inevitably spark conflict. The original mission of colonizing another star system is forgotten amid repeated struggles. To the residents of the ship after 500 generations, their entire world is this metal colossus. Their mission is survival, not reaching some distant, unseen planet. Like ancient sailors lost at sea for centuries, their descendants would forget land ever existed, accepting the ocean as the only home they've ever known. When we dismantle these barriers one by one, we realize that interstellar colonization may have been an impossible dream from the very start. But this is not failure. It's the universe giving humanity a moment of clarity. Those distant habitable planets were never backups for Earth. They are mirrors, reflecting who we are. They reveal Earth's uniqueness. Not just liquid water, suitable gravity, and oxygen, but ecosystems that have co-evolved with humanity for millions of years. From oxygen-producing cyanobacteria, to waste-decomposing bacteria, to forests that stabilize climate. These are extraordinarily rare coincidences in the universe. The mirror also reveals the fragility of human civilization. Our bodies, our technology, our societies, are all custom-built for Earth. Leave it, and we become fish out of water, struggling just to survive. So the true meaning of space exploration has never been about finding another Earth. It's about learning to cherish the one we have. When we see distant planets as deserts or frozen wastelands through telescopes, we better understand how precious Earth's green forests, blue oceans, and even raging storms truly are. Protecting Earth's ecosystem, developing sustainable technology, and avoiding internal collapse of civilization, are the only real paths to humanity's survival.